Venus's superrotation. Daily heat cycles drive extreme winds. Venus, Earth's inhospitable twin, is famous for its runaway greenhouse effect and crushing atmosphere. But beyond the surface heat, the planet harbors another extreme. Winds at cloud level that race around the planet 60 times faster than the surface rotates, a phenomenon called superrotation. While scientists have long known about this bizarre atmospheric behavior, the exact engine driving it remained unclear. Now, new research from Lai et al. Points to a surprising culprit: daily heat cycles. The mystery of Venusian winds on Earth. Our atmosphere generally rotates with the planet, not on Venus. There, clouds whip around the globe at over 100 meters per second, faster than a Category 5 hurricane. This is especially strange given that Venus spins incredibly slowly one day. There lasts 243 Earth days. The question has always been, what keeps the atmosphere moving so fast? Previous theories centered on interactions between atmospheric currents, planetary waves, and thermal tides. But the precise contributions of each process were murky. New findings: daily thermal tides. The latest study, published in ES, leverages data from the European Space Agency's Venus Express and Japan's Akatsuki satellites. These missions tracked how Venus's atmosphere bends radio waves, allowing researchers to map thermal tides, patterns of air movement caused by sunlight heating the planet. Traditionally, scientists believed that semidiurnal tides, 2 cycles per Venusian day, were the primary driver of superrotation. However, this research reveals that diurnal tides, 1 cycle per day, play a far more dominant role than previously assumed. The team's analysis, including the first detailed look at thermal tides in Venus's southern hemisphere, shows that these daily heat cycles efficiently transport momentum upwards into the thick cloud layers. The diurnal tides appear to be major contributors to the rapid winds, suggesting that daily heating is a key factor in sustaining Venus's superrotation. Why this matters: understanding Venus's superrotation isn't just about this one planet. Many rocky planets orbiting close to their stars rotate slowly, making them prime candidates for similar atmospheric phenomena. By unraveling the drivers behind Venus's winds, researchers can gain insights into the atmospheres of exoplanets and how they behave under extreme conditions. Further clarification of diurnal tides is still needed, but this work represents a significant step towards understanding the dynamics of planetary atmospheres beyond Earth. In short, the Sun's daily heating of Venus is a powerful engine that keeps its atmosphere churning at impossible speeds. This discovery underscores how dramatically different planetary atmospheres can be and highlights the importance of thermal tides in shaping the weather on other worlds.